Hello everyone and welcome to Lesson 3 from Chapter 7, Triangles. We will continue looking at the question, how does geometry help us describe real-world objects? And for our vocabulary, we're going to look at acute triangle, right triangle, obtuse triangle, scaling triangle, isosceles triangle, equilateral triangle, just the triangle, and congruent segments. For a math symbol, we have the symbol of a triangle. Let's look at the real-world connection. Julia practices jumping on a ski ramp. The front of the ramp is a triangle, like the one shown below. So you see here we have the shape of a triangle, and you can see that we have a right angle by this label that you see there. It's a right angle. And we have 80 degrees on this line. The 80 degrees is from this line to this line. Imagine this were the base. Imagine that was the bottom line. You can see that it doesn't go straight across like a 90 degree. It's slightly less. So it's an acute angle. And over here we also have an acute angle. Well, what's x? Draw an x through the type of angle that is not shown in the triangle. Which one is not the type of triangle? We see that we have a right angle right there, so clearly it's right. And we have acute angles, so it could be acute, but we do not have anything obtuse. So we can go ahead and draw an X right there. Question 2. Measure the unknown angle. This is where you would use a protractor, and you align the bottom line of the protractor with the center of the protractor right here on where the two lines meet. Describe the relationship between the 80-degree angle and the unknown angle. Well, this angle right here plus this angle have to equal 90 degrees because this is a right angle triangle. So these two angles together have to equal 90 degrees. And by the way, going back to question 1, I realized I did not put an X over the acute. This is a right angle triangle. I hope you caught on to that. This is a right angle triangle, not an acute. An acute would be all three angles are less than 90 degrees. That would be an acute triangle. The sum of both angles equals 90 degrees. Therefore, they're complementary angles. Question 3. Draw a triangle with one obtuse angle. Obtuse meaning more than 90 degrees. So I would draw a line like this, and instead of going straight up, I would angle it out a little bit and bring it right down here like that. So I know that this angle right in here is more than 90 degrees, and there's my obtuse angle with an acute and another acute. Please draw this obtuse triangle the way you see it so that I know you've watched this video. Is it possible to draw a triangle with two obtuse angles? Is it possible to have two angles like this? Well, let's see. If I were to go more than 90 here, and then at this one I go more than 90, which means I wouldn't go up, but I would go back out, I would continue to go outward, almost making a boat. Do you see that? Like the bottom of a boat, a ship. But so we couldn't. We wouldn't be able to. Obtuse and another obtuse, and a triangle is supposed to have three sides. We would not be able to. So the answer is simply no, because with two obtuse angles, the triangle would not be a closed shape. Let's review the types of triangles. We have an acute triangle. All angles, all three angles, are less than 90 degrees. They're all acute angles. Then we have a right triangle, like the one we had in the example with the ramp. One of the angles is a 90-degree angle. And this one looks like it's 90 here, 45 and 45 here. And an obtuse triangle, one of the angles is obtuse. So you see this 90 degrees would be straight perpendicular to this baseline, but it goes further out, so it makes it obtuse, greater than 90 degrees, and then two acute angles. Scaling triangle is no sides are equal, no sides are congruent. Okay, so all three angles are different. Isosceles triangle is at least two sides are congruent. Okay, so here we can see that this side will be congruent to this side, okay, and this side is different. Isosceles, you can think of the word iso, to isolate, one isolated angle. And then equilateral, all angles are equal. All three would be the same. It is very important that you memorize these triangles. If you need to pause the video now and review this for another minute, maybe covering it up, covering it over with your hands, the names, and saying them, just to practice memorizing them. Remember, now we're going to practice classifying triangles. So let's look at the triangle on the roof of this house. Let's see everything that we know. When we look at this triangle, we're trying to see if there's one of the three angles is greater than 90 degrees. Or if we have a triangle or a right angle, and we see up here that this is greater than 90 degrees. If it were 90, it would go like this and straight down this way. Do you see that? It would go down straight this way. But it's further than 90. It goes out like that. So we have an obtuse. And then over here in this angle look to be congruent. Okay, the same. So what do we have? The triangle has one obtuse angle right there and two congruent sides. So it's an obtuse isosceles triangle. Isosceles because one of the angles is isolated. One of them is on its own while the other two are the same. So two angles are the same while one is different. So it's obtuse isosceles triangle. Okay, classify the triangle shown by its angles and by its sides. Here we have a ramp. We have to classify by its angles and by its sides, right? We see that we have a right angle triangle. So this is a right triangle. What kind of right triangle? Okay, we have a right, and we know that if this is 90, these two numbers will complement one another to make 90, and they're going to be different. You can see that this one is maybe around 70, or maybe even 80. No, I would say about 70, and this one's about 20 degrees. It's an estimate. You can take your protractor out and put it right up to the screen if you like and check. So this is a right scaling triangle. We identify the angles and then the type of triangle, the sides. Right scaling triangle. Angles of a triangle. Here's some words we need to become familiar with. When we talk about the sum of the measures of any angles, we're talking about the total when added. So the sum of the measures of angles of a triangle is 180. If we were to measure this angle plus this angle plus this angle, it would be 180 because it makes its way all the way around the protractor. Here's what we mean. If you match the baseline of this triangle to the baseline of the protractor, you'll see that we go through all of the degrees, all the way around to get back to the baseline, which is 180. You see it right there? Okay. So this triangle that we have on the top here could be drawn right in here. Now, don't mind my drawing. It's not going to be perfect, but it would look something like that. Okay, so that it makes the 180 degree turn all the way from this angle to this angle. And this is why angle X, Y, and Z when added equals 180. So now that we know that, we have a triangle here. It looks to be an obtuse, an obtuse scaling triangle, right? And we have 119 here, okay, plus 43, and we're missing one angle for it to be 180. So we have 119 plus 143 equals, plus Z equals 180. The way you could write it is measure of angle Z plus 43 plus 119 is 180. And then we invert the operation, right? We can take the 119, okay? Actually, that they don't do one number at a time. They go ahead and just add these two because it's already addition. So add it together, it becomes 162. Okay, you subtract the 162, you invert the operation, and subtract the 162 from this side so that you isolate your z, and z equals 18. So the measure of z is 18. Okay, if you think you got it, let's try this. In triangle ABC, if measure A equals 25 and measure B equals 108, what is measure Z? So let's go ahead and draw it out. We know one of the angles is greater than 90, so it's greater than a right angle. So this will be an obtuse triangle, right? This will be my 108 right here on the top, 108. And the other, this will be B, okay? And my measure A, I can just make it this one. Okay, this will be my measure A. This one could be 25 degrees. So I'm looking for measure C right here. So we have measure of angle C, the measure of angle C, plus 108 plus 25 is 180. We know that all of this is 180. So let's go ahead and solve it. I consolidated the 108 right here. Okay, the 108 plus the 25 equals 133. Now I'm going to invert the operation by bringing this plus 133 over to this side to subtract it so that it looks like this. And I get measure of angle C equals 47 degrees. And for example 4, here we have a real-world example of how we can use the equation we've been using to solve the missing variable to find the missing angle in a triangle. The Alabama state flag is shown. What is the missing measure in the triangle? So we have 110, 35, and we understand that, well, 110 right here plus 35, what are we missing for the other? 35 plus 35 would be 70, plus 110 would be 180. So x is 35 already. We can tell just by looking at it. Okay, so this is a looks to be an obtuse isosceles triangle, right? Because these two are the same. This one's isolated, so it's an obtuse isosceles triangle. And here we have how they did the equation. We have x plus 110 plus 35, x plus 110 plus 130, but plus 35, sorry, equals 180. Consolidate these two numbers by making it 145. Subtract the 145, and you get x equals 35. Here's a sneak peek to our guided practice. This is how we will start next class. If you don't think you could do any of these on your own, please feel free to go back to the video and look at examples 1, 2, 3, or 4 for clarification. See you in class.